Sound, the fundamental source of communication, is often used in various applications such as technology, entertainment, and nature. But how does it actually work? Sound is produced through a source causing vibrations in mediums such as gases, liquid, and solid. For example, when a speaker is played, the vibrations from the speaker causes layers of particles to vibrate, which causes a series of compressions and rarefactions between the air particles that travel outwards towards the ears of the listener. Moreover, the direction of which air particles vibrate in is parallel to the propagation of sound transmitted in the form of longitudinal waves. Now that we know the basics behind sound propagation, let us experiment on factors affecting amplitude or loudness of sound waves. As we may know, the louder the sound produced, the higher the amplitude. However, does the distance, presence of light, and presence of wind affect the amplitude of sound waves? To find out, the following equipment are used: one measuring tape, one amplitude recorder, one source emitting sound at constant frequency and volume of 1000 Hz at 1000% volume. Each take will last 5 seconds long and the amplitude comparison will be shown on screen. Conclusion: the further away from the distance from the sound emitted, the lower the amplitude and loudness of the sound recorder. This is because as sound waves travel further away from their source, the more spread out their energy becomes. You can see how this works in the figure here. As distance from the sound source increases, the area covered by the sound waves increases. The same amount of energy is spread over a greater area, so the intensity and loudness of the sound is less. This explains why even loud sounds fade away as you move further from the source. Conclusion: no. The amplitude or loudness of sound waves are not affected by the presence of light. This is because sound is made of vibrations in mediums, while light is made of vibrations in the electric and magnetic fields. The presence of light does not interact with the way sound travels. Hence, the amplitude of sound waves emitted are largely unchanged. Conclusion: yes, this is due to the presence of wind causing sound waves to bend towards the ground through a process called refraction.